Imagine training a large language model to solve complex reasoning problems, math puzzles, code challenges, logical deductions, using reinforcement learning. You give it rewards for correct answers, and over time it gets better. But then progress stalls. You're not stuck on a hard problem. You're stuck because the training signals have vanished. The model either sees problems it can solve too easily, no learning gain, or ones it can't touch at all, no feedback, no reward. And worse, it starts memorizing patterns from a narrow set of examples, not generalizing. This is the hidden bottleneck in modern reasoning AI. And today, we're diving into a new framework that solves it. SCALER, Synthetic Scalable Adaptive Learning Environment for Reasoning. At its core, SCALER tackles two fundamental challenges that derail long-term reasoning improvement in LLMs. 1. Reward signals that decay over time, when the training difficulty no longer matches the model's evolving capabilities. 2. Overfitting to repetitive patterns, when the model learns a limited set of templates instead of broad reasoning skills. To fix this, SCALER introduces a dual-engine system. First, a scalable synthesis pipeline that turns real-world programming problems into infinite, verifiable reasoning environments. Second, an adaptive multi-environment reinforcement learning strategy that dynamically adjusts difficulty and refreshes the training environment set, so learning never plateaus. Let's break down how it works. The foundation is environment synthesis, the ability to generate an endless stream of diverse, verifiable reasoning tasks from real programming problems. Take a problem like, given a sequence of numbers, find the maximum sum you can achieve by flipping the signs of a prefix and a suffix. That's a concrete, well-defined task. But how do we turn it into a trainable environment? SCALER's pipeline does three things. 1. Extracts meta-information. It identifies scale parameters like the length of the sequence and output requirements. Is the answer a single number? An array. A string. Crucially, it filters out ambiguous or ill-formed problems. Only those with unique, verifiable outputs survive. 2. Generates test cases automatically. A synthetic agent creates randomized inputs that conform to the problem's constraints. For example, generating a sequence of length 100 with random integers, all within bounds. 3. Validates the generator. It runs two checks. Breadth check. Multiple independent solutions must agree on the output, ensuring consistency and uniqueness. Deep check. Multiple runs of the generator produce diverse inputs, preventing overfitting to a narrow pattern. This creates a verifiable, controllable, and infinitely scalable environment. Not just one problem, but thousands of variants, all with guaranteed correctness. Now here's where the real innovation kicks in. Even with infinite data, the model can still get stuck. So SCALER adds a real-time difficulty controller. Each environment has a scale parameter, like array length or graph size. The controller monitors the model's online accuracy during rollouts and adjusts the difficulty dynamically. If the model is solving 90% of problems, the controller increases the scale, pushing the model toward its capability frontier. If accuracy drops below 50%, it reduces difficulty, preventing reward sparsity and exploration failure. And because the system works with real-valued difficulty scores, it uses a smart rounding strategy. For example, if the target difficulty is 2.3 and you need 10 instances, you generate 3 at level 3 and 7 at level 2, averaging exactly 2.3. This ensures that most sampled problems are neither trivial nor intractable, keeping the reward signal strong and continuous. But scaling isn't just about difficulty, it's about diversity. Even with a single environment, you can generate infinite problems. But if they all follow the same template, same structure, same failure modes, the model will eventually master them and stop learning. So SCALER introduces an environment curation mechanism. It maintains a dynamic active set of environments, say 64 at a time. Each one is evaluated periodically. The system tracks the slope of difficulty over time. If the difficulty stops increasing or accuracy stagnates for several steps, the environment is flagged as saturated. 2 heuristics accelerate this. If the model fails for 5 consecutive steps, unlearnable. If the difficulty hits the maximum for 5 steps, right arrow trivial. When retired, the environment is replaced by a new one from a large pool, but not discarded forever. It's returned to the pool, ready to be resampled later. This creates a continuous cycle of novelty. The model keeps encountering fresh challenges, avoiding the tourist pattern of shallow exploration. Let's see how this plays out in practice. In experiments, SCALER consistently outperforms dataset-based baselines, like math and DeepMath, across 5 major reasoning benchmarks: Math 500, AIME 24, AMC 23, MMLU Pro, and BBEH. While baselines plateau early, after just a few hundred steps, SCALER keeps improving for over 1,000 steps. Why? Because effective sampling rate stays high. Most prompts remain near the model's current capability boundary. No more all correct or all wrong regimes. And when you scale up the number of environments, from 8 to 64 to 512 to over 2,700, performance keeps rising. More diversity equals more sustained learning. Even with just 8 environments, the model continues to learn, thanks to the difficulty controller pushing each one to its limit. But here's the key insight: scaling environments alone isn't enough. Without the difficulty controller, performance drops. Without curation, learning stalls. Ablation studies confirm both components are essential. So what makes Scalar different? It's not just another RL framework. It's a co-adaptive ecosystem, where the model and the training environment evolve together. Synthesis pipeline turns real problems into infinite, verifiable, difficulty-controllable environments. Adaptive difficulty controller keeps training near the capability frontier, no reward decay. Environment curation prevents overfitting by continuously refreshing the training distribution. This isn't just incremental progress. It's a paradigm shift from static datasets to dynamic, self-sustaining reasoning ecosystems. The future of reasoning AI isn't about bigger models or bigger datasets. It's about smarter training environments, environments that adapt, that challenge, that evolve. Scalar shows us that true scalability in reinforcement learning for reasoning lies not in data volume, but in environmental intelligence. By designing environments that think with the model, not just for it, we unlock the potential for long-horizon, generalizable reasoning. And if you're building the next generation of reasoning agents, this is where the real work begins.